Well, hi, good morning, and thanks so much for joining me here in my shop. We're going to be starting on this classic style of radio, many of which I've worked on already. And this one looks very much like the radio that my parents had when I was a kid. This was the radio, where was it? Well, for a while it was in their bedroom. So a little bit of nostalgia for me. I don't think it was exactly like this. Could be, it could have been actually. So again, this radio is in condition unknown for me. This is my radio. I purchased this in a group of radios, and so the word is it's working. I'm gonna pull that out. Working means various things. So far with this group of radios, working hasn't meant much at all. Really. So they're terribly distorted back. Baby Champ. Can you see that picture? Yeah. Baby Champ radio. It's got 20 written on it, 20 written on it, 20 all over the place. That's 60. Tube locations. Warning, any person installing or operating this is going to get in trouble with the Canadian law. Model 5000. 30 watts. Made in Canada. Northern Electric Company Limited, Montreal. So this was made in Montreal. You see a lot of dirt and dust in there. And it looks like this thing got a quick wash over because it doesn't look very good on the top. Looks like somebody just took a mop to it, in fact. So there's a couple issues here with this cabinet. First one is it's got a crack running all the way along the edge here, right around through the corner. It kind of spiders at the corner. It comes right around the front here to this distance. So no picking up. Actually, you can't pick this up by the back. But we got to do something about this, or this is just going to progress, I imagine. I can't think a long straight crack didn't happen because somebody dropped the radio. And the other problem, unfortunately, is this plastic is all cracked through here. Looks like it took a smash in the front at some point. It's probably quite brittle. So what exactly I can do with that, I don't know. I can always remove it, but that would kind of take part of the look. Part of the look is this plastic piece here. Too bad, but you know, I'm missing a few pieces myself at this point in my life, so let's take it out and take a look at it. I wouldn't dare turn this guy on without looking at it inside first. Very nice knobs. It's just really flat bottom. That gives you an idea what this really should look like. What's that say? 30. Sound. I don't know what that is. BN33. I don't know what that says. 338? I don't know. Okay. That's not the model number. It's 5000 is the model number. How do you get this radio out of here? So it looks like these have got corner screws. There's 2 of them left. It looks like that's what's holding the whole radio in. These 2 screws are holding the back to the radio. Got to be more holding this in, isn't there? I'm really surprised that this is all it is, but now these screws are going right into plastic here, and there's a high likelihood the plastic will break. This screw is loose, which is actually good. You don't want to tighten anything up into these plastic cabinets anymore. This is a machine screw, and so is that one. But I believe it's common to find machine screws in this kind of plastic. I don't think this is Bakelite. It's coming out. So it's just those 2 screws holding that in there. Here he comes. Okay, a little inspection of the cabinet here. See the crack in the plastic goes right through to the edge here. Same thing over here, right out to the edge. It looks more like a age-related stress cracking to me. Doesn't look like it got a kick. Okay, and what about that crack up in the corner there? So, see how they basically a reinforcing piece here in the corner, and then they drilled it and threaded it for the screws to go in. And the crack is going right along the edge of the reinforcement piece. Right along just this inside edge here. No other signs of cracking in here. There's something. No. Oh. Is that a crack? No, that's where I scratched it. Yeah, no more cracks, just those. Okay. Okay, Baby Champ radio. Here you are. Doesn't this look a lot nicer now that that dirty plastic's off it? Speaker's in good shape. Looks like it might have a little bit of a... maybe not. Looks to be in good shape. Radio looks okay. Hey, we can see underneath it here. There's no bottom plate. Let's take a look. Let's take a look right away. What's here to be seen? Oh, Mr. Original. Oh, not quite. Not totally original. You see that right there. Looks like that's the only thing that's been done. Look at these dust bunnies. Oh. Really? How did somebody do this? How did they put that in there and these dust bunnies be here? They did this like 5 years ago, 10 years, 20 years ago? This coil looks... There's another coil. Looks a little funny in here. I was fooled by the last radio where the coil looked like it had a break in it when it actually didn't. There's an awful lot of dust underneath here. Here's another one of these molded capacitors where the paper sleeve has just slid on it. Why would it even slide? So it generally looks okay. So it's like some kind of a sleeve put on the power cord here. This is a replaced power cord, I'm pretty sure. That would be the case. Well, no reason not to turn this one on. 1, 2, 3, 4, 5, 6, 7 wax capacitors at a glance. 1 electrolytic installed. So the old capacitor must still be in the circuit, I would guess. Well, let's check it out. Let's see what it does. Okay, so I'm using a dim bulb system to control the amount of power that gets to the radio in my shop. I like this kind of system. These are the bulbs. Control panels just up here where my hand is. This switch selects power through the bulbs or power straight from the not from the outlet, but from an isolation transformer that is powering this. That's, in a nutshell, that's the story here. Here we go. Switch is off. You wouldn't expect anything to happen, but you never know. Okay, so this little box will report the voltage at the outlet, 123 volts. And when I turn it on, the power going into the radio, the current from going into the radio will go through this light bulb and light it up a little bit. Maybe. And we're going to find out. Does this radio really work? Here we go. And a little pilot light came on. Turn it up a little bit. I can see the heater coming on this tube. One tube heats, they all heat. Bit of a hum. This is out of the cabinet, so I guarantee you, we put this in the cabinet, that hum will really be distinct. Okay, right in here. This is where the French station I like to So there it is. You can pick it up. It's not very strong. Let me show you a couple more down here. I think that's 640. That's 690 or 590. 590 is a sports channel. It's quick to recognize. It's right on 590. So there, it's accurate, and its reception is not so bad. So other than the hum, yeah, this radio works. But I'm going to get rid of the hum on it. Excuse me. So that's the first challenge. Not much of a challenge really. It's quite straightforward to eliminate the hum on a radio like this. Okay, turn this straight upside down. Fantastic. Great. Great. Let's take a little closer look now. So why would somebody make this attempt at clearing the hum? It didn't work. It's still humming. Excuse me. So I can see what they've done is they put the capacitor. You can look at this, the filter capacitor that came with the radio. You can see the ground terminal back under here. It's easy to recognize. Another ground terminal over here has black wires attached to it down under here. And then there's two posts coming up out of the more central part of the capacitor. These are the two positive terminals of the two capacitors that must be in here in the filter capacitor. So he's just put another on top and hoped that would be enough. If he'd done another one, a second one, over to this terminal, he might have got away with it. Excuse me. Very dry in my house these days, so. But what I would be more inclined to do, just what I did with the last radio, is lift off these terminals, or lift the wires off these terminals. Get off the old capacitor, basically. There's another. There's a third terminal back under here, coming out, heading for what I imagine to be the output tube. So it's probably a 3-part capacitor, 2-part for the power filter, and 1 part as a cathode bypass capacitor. We'll find out as we go along. And a little closer look at this. I think it's just fine. I just was suspicious a wire was broken there. I don't think so. All kinds of dust. Yuck in here. So the next thing I need to do is plan out how to replace this. There's lots of space in this radio, lots of opportunity to do this. It's really not going to be that big a deal as compared to some other radios I've done where you really have to figure out how you're going to insert these capacitors inside the radio. I did a very small one. Last radio I did, very, very small radio, physically small. Really had to plan it out. Just looking everything over carefully here before I commit myself. Considering the radio is basically working, I can't be too concerned. Okay. Um, in this radio, it just might be possible to chop those terminals off that old capacitor, because I have enough room to get my tools in there and really just cut them right off. And that's by far the most convenient way of doing this. This capacitor, we can assume he's put it in with the value 47 at 160. That's perfect. I assume that capacitor is just fine. So really, this is a matter of cutting some terminals free. Let's see if I can do it. It's easier said than done. It's a pretty big cutter here. Just working it into place. I'll take a closer look before I really mess up here. It looks very, very good. Okay, here we go. I will cut. Will not cut. I got too much in there. Let's nip it. Nip it. Nip it again. Did it just come off? No. Try it again. What's holding it on now? What's holding it? All the way through there. See, it's a pretty brutal operation here. I got it. That's one. Just got to do that 3 more times. Let's try this one here. This one only has 1 wire hooked up to it, and it's the negative return. No, it's not. No, it's not. No, don't say that, Jim. Not the negative. It's the one going over. I don't have to cut the terminal off. I cut the wire off. It's easier here. And then we'll just put a capacitor onto that wire and I'll pull it way up here. I won't forget about it. Hopefully. And then the last one. Any big bad cutters here. Come in there. There's various ways of approaching this problem. I just convinced myself I got a shock. How could I get a shock from this? Oh, easy enough. It was my imagination, but good thing. So I actually been stupid enough to leave the power on while I was doing this. Okay, I think I can get in there now. Like that, like that. Nope, nope. Down there, perfect. Oh, popped off. Tough to get in there. What's on there? 2 wires and a capacitor. Even cutting this free, it doesn't solve all problems in the radio. You now have a problem with these floating terminals that have to be. There we go. That have to be. Got them. Okay. So what remains connected to that capacitor shell now are these ground wires, or B- wires, which are fine. You can leave them there. Let's see if we can bend these terminals out a little bit without doing too much. Look at this. The guy's capacitor popped off the terminal here. Solder job. Here I am trying to preserve something that's not worth preserving. I just want to spread out the leads on the capacitor there, on the resistor rather. There we go. 1 more capacitor installed. 2 more, because I have to do this one too. We better take a look at the schematic before I get too far on this. On this guy. Let's do that next. Study up the schematic. Okay, let's take a look at the schematic here. So again, this is for the 5000 The other radios I've done, baby champ radios, have all been 5200s, a different number. So I don't know what the difference is. I could be quite a bit of differences in here. So what we're mostly interested in is the power supply right now. So we'll just come down here by the power supply, and 40, 41, 43, 44, 38, 38. What are you doing with the numbering system here? 27, 29, 26 maybe there? Item. So they've numbered the components differently in this schematic from most. They haven't collected them by type of part. They just numbered everything. I guess probably starting up here somewhere. 3, 5, probably 1 is up here somewhere. I just numbered everything serially all the way through the radio. So that means this list is mixed up. Yeah, capacitors, resistors, switch coil capacitors. Okay. Voice coil impedance. Nothing funny going on with the speaker. Modification. What is modified? What modification? Okay, so I don't know what that is, but okay. Power supply. The input side of the power supply, it looks like 100 and probably it'd be 161 volts or something like that. Output side here, the far side, is 78 volts. 78 volts on the red wire, feeding detector and these two tubes at the front. And yeah, from the far side of the power, this is the more highly filtered B plus here. The less filtered B plus is okay to go to the speaker in the output tube, which it does. Hey, wait a minute. What's going on here? Oh, okay, so I looked at these and I thought these were diode plates here, but they're not. What they're showing is that this is a beam power tube, and these are the beam forming plates, if you like, that are symbolically shown here. Filter capacitors, these two, 43 to 44, 40 microfarads, okay? Two 40s here, and then the other one would be bypass on the here, right here, 27, 20 microfarad, 25 volts, so that's typical. So the last radio I did, they did not bother bypassing the cathode resistor, but in this radio they do. So for me to do the power supply filters, pretty simple thing. Just do these two, and then figure out where to put this last one. Somewhere in the radio. Maybe I'll find it right near. I'll put it right near this resistor, perhaps. That wire, the black wire, will lead right to the spot. The black wire's there. This is easy to do. Okay, let's go do it. That one's already done, except the negative lead has come off. Where was that negative lead? Quite a few places here. They've made use of all all three ground points or shell points on this capacitor. They have wires on them. I think that's just fine. I don't think that's a problem at all. This should really go down to one of these ground points. It must have been going down to the one back there, I'm going to guess. Okay, let me bring out another capacitor. I'm really low on this particular kind, as in I don't have any anymore. So I have to put the next voltage rating up in there. Spend an extra 25 cents here. Okay, so I've got the one additional capacitor installed here. This is the one that somebody else had installed. And I was just about to prepare the wire here and hook up the bypass capacitor, and I just followed the wire way over to here, and that got my eye on this resistor. Let's take a close look at this resistor, because I think there's something amiss here. Should be okay. I'll take a look at this resistor. Aha! That's what I thought I was seeing. Look at that. Now that's very, very interesting. Exactly what has happened there. Let's make a couple observations. First of all, it's in the center of the resistor from the ends. That's the hottest area of the resistor. This is where, if there's a heat effect, you're going to see it here first, I would imagine. The cracks have a shape. It looks like they're wandering around crystals. But that case that's cracked isn't crystalline. I don't think it's crystalline in any way. It's amorphous, I would imagine. Maybe not. Or sitting here heating up, being hot for a long time above a certain temperature, perhaps that's caused some chemistry in this material, the plastic or whatever this is that the resistor case is made of. So it may have caused chemistry. Part of that would be volatile components leaving the plastic matrix or plastic soup, whatever they call it. So it could be something coming off, and then there's less material left in the plastic, and so something's got to give. And so these cracks open up, like ground drying out, and the moisture disappears. And when the moisture disappears, the ground cracks. But it wouldn't be moisture. So I think this is a sign of overheating in this resistor. Maybe not. It could just be just a bad resistor to use in this position for this length of time. What about the general mileage on this radio? So if I look at other parts, trying to figure out how much use this radio's gone to, there's nothing here that tells me this radio was on a lot. If I'm looking for blackening on these tube sockets or around them, especially the rectifier tube. So this is the rectifier. Which one? This is the rectifier tube here. So I don't think this radio got a lot of use. And I'm going to guess what happened to this resistor is just more age than anything, but wow. So you think this thing is still correct in value? The value is something red-black. That first band, I'm sure it's lost its color. Something red-black. Let's find it on the schematic, and then I'm going to cut it out, and then we're going to test it. I'm not going to test it in the circuit. Quick, everybody, to the schematic. So we're looking at the resistor. It's probably this one. That's off of pin number 4. So I'm going to look on the radio and count the pins and see if that's pin 4. So that resistor is hooked up to pin number 8. No, wait a minute. No. No. Don't fool me now. Oh, son of a gun. It comes from the rectifier tube. Pin number 1, 2. Oh, they're numbered. 1, 2, 3, 4, 5, 6. Pin 7 on the rectifier tube has that resistor on it. Pin 7 on the rectifier tube. They didn't number the pins. They didn't number the pins. They didn't number them up here either. Why did I think I saw that? I thought that was pin 4. Looks more like 0.4 volts or something in there. Something 0.4 volts. Okay. You little bum. Okay, so how are we going to sort this out now? I can't read that number exactly. 28. Well, I know what this will be, a few hundred ohms. So let's go look in the parts list. Oh, it's all over the place. For a few hundred ohms, around number 27. 10 meg, 270 ohms. There it is. 20, what? 22 A and B? 22? What did they do here? 22, 22A? Is that asterisk sitting here? 22B. 22. I don't know what they're trying to do here. Okay, so a resistor 270 ohms, half watt. 270. So that would explain the so the red band. No, that's not a 27. Unless the colors have changed dramatically. I see a 22 or something like that nearby. Not on the same pin. Well, the bypass wire goes right to the big resistor, so that has to be the cathode resistor. And that would mean the other end of it should be going, well, it should be going to this B minus wire, but it doesn't seem to be. It seems to be going straight onto one of these terminals here all by its lonesome. How does that work? Okay, so this big resistor I'm questioning, one terminal is hooked up to a terminal on the rectifier tube just all by itself. There's no wire leaving it, and this terminal on the rectifier tube is one of the heater terminals. There's 3 heater terminals. One's the center tap. This is one of the outside ones. So the heater current is flowing through this resistor. So this is a compensating resistor for the heater string in this radio. In other words, what I'm suggesting is the heater string itself can't drop 120 volts, so helping it out with this guy to burn up some of the, take some of the pressure off is literally what it's doing. So where is that in the schematic? Watch this. You know, this is the way it goes with these things. Check this out. So here's the schematic, and I'm not exactly sure about that resistor yet. I'm still trying to prove. I think it might be this one, but it also might be this one right here. This is the one that's in the heater string. See, they're all in series here, and this resistor's in series, and it just goes in this heater string for this last, or heater for the last rectifier tube here. Number 30. Okay, let's go look at number 30. So we come down here. 22, 25, 20, 29. 31. Wait a minute. Where's 30? 29. What happened? It's over here. 14, 15, 29, 31. Where's 30? So 30 doesn't appear. 30, it didn't make it in the list. If this is 30, it sure looks like 30. Son of a gun. It could be 30 something else here. This could be completely wrong. This could be some other. Well, you know what? It goes to, so the 35L6 output tube goes to pin number 2, this resistor. So it goes here. I got it here. Do I have it there? Yes, I do. I have it there. So I don't think there's any doubt it's this resistor. And it goes over to pin number 2. Let me check. And I'm counting. Yep, it's pin number 2. Pin number 2 on the output tube. So this is definitely it. 30. Now, how am I supposed to figure out the value of it? Is it hidden somewhere else? Is there a note or something funny going on here? All voltages, line voltage wrong. Wiring side of tubes shown. Modification. There's nothing in here. Further data on sheet 90. Maybe there's a nut, you know, this has been cut and paste. How much you want to bet they cut it off down here? They cut off number 30. You know, I have another diagram here. I have more to this radio. I have more to the schematic rather. Let me get that up on the screen here. RF alignment. Oh, look, There's some numbers and parts. So the number I'm interested in is over here. It's down here. Oh, here's model. Model 5000-1, model 5000. So I think I have model 5000. Oh, look at this picture. How is this going to help me? Oh my gosh. So we're looking over here. There, see, right there, 30. And it's probably pointing at the resistor in this dark shadow here. Doesn't tell me the value. No, I'm looking for another parts list. I thought I saw another parts list. Parts list for all I know, it's a different version of the radio. There is something else. Let's go a while. We're going looking. Let's go looking. So this is the website, Radio Museum. And see this gigantic parts list here. So I've downloaded the first 2 pages. Let's go after this one. Looks like a parts list. Oh yeah. I can do it right here. Models 5000, 5001. Capacitors. Oh, it's just the rest of it over here. 20, 36. Why aren't they done with this page? A lot of models here. This is it. Capacitors. I didn't list the resistors here. Huh. I got all excited about nothing. Does the number 30 appear in here? No. Okay, we're going to end up having to reason out what the value of the resistor should be that's in there. I don't want to do that. You know, it's the first number in the resistor value that's not visible. If I could get the first color band correctly, I wouldn't care about the rest too much. The black one you would. Let's think about. So black is a 0. So this is going to range between 99 ohms and 1 ohm. We know that's a 2. It's something 2. It could be 12, 22, and onwards, all the way up to 92. The likely value here is going to be, I don't know. I have to calculate it out. So, okay, I'm going to fiddle around with a piece of paper and a pencil for a few minutes here. Okay, let's take a close look at that resistor and see what we got here. Wow, so cracks are all over the place. They're just very shallow in most areas. So what I'm quite interested in is identifying the first color on this. It looks like it's white, but what? I see some color right in here. Bluish color. Gray. 820. Is that what gray is? Gray is 8. And there's those cracks. Wow. So if the resistor overheated, why did it overheat? Did it overheat because of its own internal failure of some sort? Or did it overheat because it was being brutalized? Or is it just got a heavy duty, and inevitably if you opened up these radios you'll find a lot of them like this because it's working too hard. Look, you can see how it's necked down. The capacitor, the resistor is the volume is gone in the middle. Right where those cracks are. So something was leaving, for sure. Now let's just take another close look at this color. So I see what looks like kind of a grayish color in there, especially right in there. You know, I think that's the underlying color of the whole resistor. Yeah, that's the whole resistor was once gray. A grayish color. Well, you know, it's white. See, the fourth band is white also. I don't think there's any such white fourth band. So I think the color disappeared here. Something 2 with a black. Less than 100. Okay. Well, I am going to do some calculations here just to ballpark a few numbers, but I think we can guess roughly what that is. Okay, I'm ready for some tough arithmetic here. So these are the 5 tubes that are in there, and those tube voltages add to 106 volts. So if I could plug it into 106 volts, this radio would be happy as could be. But I can't. I'm plugging it into 120 volts. And the difference is a whole 14 volts. I have to get rid of 14 volts or so. All these tubes have the same current, or they're designed to run with the same current, of course, because they're all in series. But this tube and this tube, because of the higher voltage, can develop a lot more heat and power than these guys, even though it's the same current flowing through all of them. That's why these are so highly elevated. Typically in a radio like this 35L6 would be a 50L6. And then the 50, there's the 15 volts. There it is right there. So if you put a 50L6 in here, and I'm not saying you should, at least the heaters would be fine. You wouldn't need this dropping resistor I'm about to calculate. So the calculation is really simple. R equals pressure over flow. The ratio of the pressure is 14 volts. The current is 0.15 amps. And the answer is, I can't do that in my head, 14 divided by 0.15. 93. So a 90 ohm resistor. Now what is 9? I don't know my high colors here. So what is a 9? What is a 9? A 9 is, so a 9 is white. And that's what's on that resistor. Very, very seldom do you see that number. And the other high numbers are dark 8, dark 7, dark 6. So they're all kind of dark until you get to that. So I think I can declare that resistor to be a 92 ohm resistor. That all kind of works out. And now we can work out the wattage here. Why not? Why don't we do that? So wattage is power equals current squared times the resistance. So that would be 0.15 squared times 90. Could make that 100 to make it easy to calculate, but I got a calculator here. So 0.15 doubled. There's a root button. Okay, no square button. 0.15 times itself, because it's that number, times 90. Watts. Did I do something wrong here? Now that this looks like a 2-watt resistor, but I think it said half a watt in the. I must have read the manual wrong. So we need to handle 2 watts on 90 ohms. I got a 5-watt resistor we can put in there. That'll certainly do the trick. Oh! It's a wire wound resistor. Ooh, wire wound resistor in the cathode circuit. You know, that doesn't sound so good to me. That doesn't sound so good about doing that. 90 ohms. Let's see what my options are here. Okay, so hold on there. It's not in the cathode circuit. What am I thinking? It's in the resistor string. So I think I'll try the wire wound resistor there, because I don't think I've got a high wattage 90. I mean, I'd be lucky if I did. I should look. They're probably all wire wound anyway. Okay, so I look over the schematic a little more closely here, and what I spotted is this 2-watt resistor. I went hunting for 2-watt resistors and found one. 82 ohms. Okay. number 39. So I'm looking up here and thinking that says 30. It says 39. That's what that is. So there it is. 82 ohms, 2 watt. That's what I'm looking for. Pretty close to my calculation. Now what have I got here? I've got a 75 ohm. 82 ohms. Next one up for me, I go from 75 up to 100. I have to decide between those two, unless I want to get fancy to try to hit 80. That's where I'm at on that. Here's another one, 33 ohms. What is this one? I think number 40. It's not that, eh? No. No, because that one, well, it's one of these. Is there a number that I can read? Yeah, right. What's that number? I don't know. 28? Yeah, that would be a 28. 220 ohms. We better check this one too. Let's do that right now. We'll try reading this with it in the circuit. The bypass capacitor is missing. So I think I can. This is a valid reading. 300 ohms. And what was it supposed to be? I forgot already. 300 ohms, and it's supposed to be 220, so it's gone a little high. 300 is quite a bit higher than 220, so we'll probably change that one out too. Okay, so once again, I don't have exactly the right value. What I've got here is I need a 220, I've got a 200, and a 250. But no 220, so let's just look in the book here and see what it recommends. Typical operation under cathode bias with 200 volts on it. It doesn't have 200 volts on it. And the resistor will be, where is it in here? Cathode bias resistor, 180 ohms. So what's in here is 220 with lower B+. Well, that suggests to me putting a 200 in there should be fine, really. Control grid voltage -7 volts. Well, we can test it after we put the resistor in. You know what? I think it'll be just fine. We don't want to go too low with the resistor there because the bias will be lower, and then the quiescent current through the tube would be higher. The tube would be running harder all the time. You would never know it, but it would be. So actually, with the this resistor floating high, kind of settles down the current flow in the tube a bit. But what it does is it moves the operating point from a nice central area up, maybe up in here, which means a large enough signal come, you start banging into the limit here. So that's a risk of moving the bias point around, is you won't have enough headroom, so to speak, on the grid to for the grid voltage that's coming. Yeah, that's how I understand it anyway. So we got a resistor, another resistor, hook up the 20 capacitor, make some decisions on what sizes to put in, and you know, I'm right in this area. I should probably change this one and this one too. Now you do all these. Well, there's 4 of them here. You do this whole area. Do the whole area. Sure. Why not? So just because I like to be as observant as I can be, when I look in this radio at all the capacitors that are in there, there's one that really looks like something's happened to it. That's this one. So why does it look so different from this or this or this or this? This one has a bit of that look to it too, but not really. What happened to this guy? Especially right in this area. What's been going on with it? I don't know. I just make these observations, and maybe someday something will come to light. You know what's coming to light right now? I tell you what's coming to light. Look at that. Look at that. Let's get a look at that with the, yeah, let's get a look at that. That's a good idea. Let's get a look at that. So we have the bizarro capacitor here, and look at this resistor. That is a resistor, isn't it? Oh, that's definitely in trouble. That guy has gotten hot, I guess, and has cooked up this one, and this is what it's turned into. You know what I would say? I would say you see a capacitor that looks like this, look for something near it that looks like that. That looks like a resistor that's cracked, swollen and cracked is what it looks like. Well, things just keep expanding outwards. Let me just put the bigger camera on here. I think about the order in which I want to approach all this. So I got to get at this guy here. This guy's low down. I think we'll do it in that order. We'll figure out what's going on with this resistor. Do this capacitor. The rest are kind of out of the way. Do the other resistor. Do the other resistor. That's quite a bit of component changes in here. You know, I think I might just cut that resistor right out of there. Why fool with it in there? Because I should know what it is before I do anything to it. It's on the rectifier tube, isn't it? Yes, this is the rectifier tube. Should be pretty easy to figure out what that is. Pin number, these are numbered. Pin number 6, between pin 6 and pin 8. Pin 6 and pin 8 on the rectifier tube. Thank you. No numbers. Well, you know what? I think they didn't number them, but I think these are in order because they've shown the yeah, they've done this on each one. They've shown where the little key is located. So if that's the case, and it does say over here wiring side of tube shown, so that means it's pictorial. That means we can count these. Great. Now I said the resistor was right between, I'm looking again, 4, 5, 6 and 8. Yeah, 6 and 8. So 6 and 8. So 6 is nothing, and 8 is here. So it could be this. It could easily be this. 8 is just an open pin, so what is connected to it at that point? So at 8 it's connected to, come on, it's connected to nothing. How can that be? The other end is connected. Yeah, it's not connected. It's the resistor. So the resistor is right up here, Jim. Come on. And the other end of it then goes to top of the capacitor. That's how I want to figure this out. So I'm looking. Other end goes to. It does. It's on a blue wire, but it goes to the red connection here. Wow. Okay. Sorry I'm leaving you staring at this thing. So there's a blue wire here which comes back and ties right into the red terminal here, or the high voltage terminal. So that's bringing high voltage over. That all matches. So that resistor then, did I not? I didn't read the value of it, for crying out loud. So this will be it. Where? Here, 40. Clears a day, 40. Resistor number 40, 33 ohms, half watt. And that, yeah, I think I can see 2 orange bands on it there. 33 ohms. Perfect. That's what that is for sure. Good. Okay, so I'm going to clear all that stuff out of there and replace it all. Replace it all. And it'll probably take me much of the afternoon to get done. Great. So I've moved the capacitor. Time for another look. So this is the area that was right in contact with the resistor. Now, nothing too dramatic there, but I'm sure we're seeing heat effects. A little bit of blackening, but nothing too dramatic. You better look at the resistor. Got a big crack on it. Is that what that is? Hard to say. I'm going to read this resistor, just for fun. If it's 33, maybe I'm going to leave it, because it's in there quite nicely. I know ugly things often actually work really well. I'm an example of that. Well, maybe not the work really well part. And the answer is 33 on the money. Just leave it. It's ugly, but leave it. Apparently, it can take it. We just make sure we don't tuck up another device right up against it, another capacitor up against it. Okay, now I can carry on with the work. Let's take another look at this capacitor that I took out. So what has happened that has done this? You know, I know what's happened. I'm just going to take a good close look at it. I've never seen a capacitor quite like this one, where the wax coating, if you like, has cracked like this and pulled apart and shrunk. In fact, it shrunk, especially right in there. See, it's thinned out too. Looks very thin right around that letter C, I guess. So again, what's happening here? I think it's the same basic story I've been telling with this radio, and that is you heat things up, components volatilize or volatilize, whatever the word is, evaporate away, and what's left behind gets thinner and thinner, and eventually cracks and pulls apart because there isn't enough material. And under it, look at that beautiful writing under there. Now I got to read that value that's just below. I'm going to pick some of this off if I can. See if it just comes off. I don't think it's just going to come off. No, it's stuck on there, of course. Can I flake off a big piece here? No, none of this is about to flake off. Ooh, kind of scrape off. So you can do that with these. Scrape the old ugly wax off to read what's underneath it. 600 volts. It's not quite what I'm looking for. It'll be down here. If you scrape too hard, you'll remove the writing. 3. Maybe back here. I don't see any writing under there. Maybe up here. If I look on another capacitor like this one, it'll figure out where it's written exactly. Okay, so I'm doing that. This is an arrow box. It's written right over here. Right over here. Over here. Here it comes. Don't ruin it now. 2.02. 0.02. Quite clearly, that's a 0.02. Okay. Okay, I've got all those various replacements done. Let's just take a look and see if we can spot anything stupid here before I turn it on. Let's see. So here's the... Just looking for short circuits or anything else that might have happened. While I'm making sure everything is soldered up. Shaky. Push this down a bit. I think we're high here. Let me check it. So one last bend. Down you go. Okay, everything's underneath. Well, I think we should give it a try. That's a lot of parts changed. Chance of shake out anything that might be left in there. Chance of making an error is fairly good, but I don't think I did. I was quite careful. So I think I got it all right. But we're going to power it up with the dim lights, of course. Switch is on. I haven't put the power to it yet. Just 1 second here. Switch is on with the volumes right down. Keep our eyes on this light right here. If this goes really bright, I blew it. Okay, and 3, 2, 1, go. Perfect. This is awfully dull. I'm just watching for tubes to light up. Yeah, they're coming. Really slowly. What's our voltage here? 118. Okay, it's okay. I'll start there. One more volume. Oh! Hey! $5.90. Let's go for the French station. Okay, can't find him. Nope, no French station. So that's kind of surprising. I thought we heard it before. So those parts I replaced would probably not have any effect on the radio operation itself. Maybe on the amplifier side. I didn't really study what the capacitors were. And why don't we, as a finale here, we're going to give them a test. Test them and see how they go. Anybody want to hazard a guess? Let us start with the cooked and cracked one here. Just fix my camera a little bit. Cooked and cracked. Look at the hand. Oh my gosh, is this even worth doing? Because yes, it's very worth doing. As soon as I can find the test leads here. This is really obviously cooked badly, really badly. Certainly on the outside. Okay, 50 volts, watch the eye. What does it do? Oh, it actually comes open a bit. And that's something. I'm sure though at 150 volts there's no hope for it, so yeah. No, not going back in my box of parts, that's for sure. Now the rest of them look actually pretty good. Here's a 0.01. Looks, you know, pretty good for a 40-year-old, 50-year-old, 60, 65-year-old. That's how old these things are. Oh my gosh, really? Yeah, they're 70. Holy smokes. And same as the last one. Well, we're at the 150 point. So a little better. A perfectly good capacitor that I will open right up to 600 volts. Maybe I'd be smart and turn off the radio beside me here. Okay, so here's a sealed tight. Yeah? Often I think when companies come out with a statement like sealed tight, it's because it's not sealed tight. Okay, here we go. 50 volts. Hey, that worked good. Not so good at 150. So I'd say 1 in 10 radios doing this is surprising. The capacitors are surprisingly good, about 1 in 10. So 9 out of 10 radios, this is kind of what you see. From this vintage, back in the 40s and 50s. This is really very much a post-war radio I'm working on. This will be a radio intended to employ soldiers who have returned from the Second World War. Ready? Doesn't even open on 50. It's even worse. Got any more? Got these 2 resistors. Not worth testing. That's it. So, yeah, capacitor shot. No surprise. That's the truth. So there we go. So what's next on this radio now? I think we have just a few more capacitors to go in the radio side of it. So we should probably do a little radio testing with it, put a signal into it with a signal generator, fool around a little bit with it just before we change those ones. Get a feel for what's going on in it. Very good. Good show. Thanks for watching, and we'll move forward tomorrow. Maybe finish it tomorrow even.